Hey guys, welcome back. So what we're looking at today is lesson 14, alternate interior angles. So what we have here are angle pairs. We want to find the measure of angle JGH and explain or show our reasoning. So JGH is this angle right here. So we need to find the measure of that. Well, we know this 30 right here, and together FGJ and JGH form a line, which means 180 degrees. So we're going to take 180 minus 30, which is going to give us 150 degrees. Now, find and label a second 30-degree angle in the diagram. Find and label an angle congruent to JGH. So JGH was this one. So remember our vertical angles. So this angle over here is also going to be 150. And using that vertical angles, we know this angle over here, FGH, is 30 degrees. So that means IGH is also going to be 30 degrees using vertical angles. So remember our vertical angles. They're across from each other and they are always congruent. All right, the next thing we're going to look at is cutting parallel lines with a transversal. So a transversal is, it's for parallel lines. It's when a line meets each of the parallel lines at exactly one point. So there's one point at which each of these parallel lines is being met by the transversal. So here we have lines AC and DF are parallel. So AC, DF, they are parallel, and they're being cut by the transversal HJ. So notice it's going through DF at point E and through AC at point B. So it's only touching them each once. So what we're going to do is we want to find the 7 unknown angle measures in the diagram and explain. So using vertical angles, we have 63 over here. So that means this angle over here is also 63 degrees. Now, 63, so ABE and CBE are what? They're supplementary angles. They form a line. So 180 minus 63 gives us 117. Now, can we find this angle over here now? Yeah, we can. It's the 117 again because vertical angles. Now, how are we going to find the angles up here? What do you think we can do? We don't have any measures up here to use to solve, but these lines are parallel and they're being cut by this transversal. So what do you suppose? This angle here and this angle here, so ABE and DEH, are they the same angle? Yeah, they are. So this is 63 degrees, which means vertical angle makes this 63 degrees. And then we already solved CBE is going to be the same as FEH. So this is 117 degrees, which means this is also 117 degrees. So question number 2, which you can't see, but to keep this here so we can look at it. What do you notice about the angles with vertex B and the angles with vertex E? Well, we should notice that they're the same. So angles in the same place relative to the transversal have the same measure. So both this 63 and this 63, they're above the line, but to the left of the transversal, they're both 63 degrees. Above the line and to the right of the transversal, they're both 117 degrees. If we were to take and move that top line DF to match point B and point E together, if we just slid that down, these would perfectly line up with each other. Because the lines are parallel, the transversal is cutting them at the exact same angle, which means the angle measures between them are the same. So let's look at another one. So using what you noticed, find the measures of the 4 angles at point B in the second diagram. Lines AC and DF are parallel. It's down here. Okay, so we have one angle given to us, GEF, and we need to find all of these angles down here. So using what we know, the relative angle, GEF and EBC are in the same relative place. So this is going to be 34 degrees. The angle across from it will also be 34 degrees. And then to solve for this angle right here, sorry guys, we're going to take 180 minus 34 to find what that new angle is, which is going to be 146. Whoops, almost wrote it wrong. Which means the one across from it is also 146. So these angles, using vertical angles, we can find these. So we've done a lot with using vertical angles and knowing the relative places. There's also what's known as alternate interior angles. Now this was a little more noticeable on the previous. So if we look back up at this angle here is 63 degrees. This angle here is also 63 degrees. They're on alternate sides of the transversal, and they're in the interior because they're between the two parallel lines. Same is true with these. They're on opposite sides of the transversal, and they're inside, so they're between the two parallel lines. They're congruent. So that's a rule. So anytime you have a pair of parallel lines cut by a transversal, the alternate interior angles are going to be congruent. They're going to be the same measure. So that can help you when you're taking and trying to solve these and find all of these missing measures, because sometimes there could be a lot of missing measures and a lot of things to have to try and find. So on to our last one. For number 4, the next diagram resembles the first one, but the lines form slightly different angles. Work with your partners to find the 6 unknown angles with vertices at points B and E. Sorry. So let's look at this top part first. So here we have 108, which means this angle over here is also going to be 108. So then to solve for this angle over here, we want to take 180 minus 108, which is going to give us 72. So this angle here is 72, which means the angle across from it's also 72. Now, what do we notice? This is 72, but the alternate interior is 63. Now, we didn't do anything wrong. What do you notice about lines DF and AC? Are they parallel? They aren't. So this only works, alternate interior angles only works when the lines are parallel. So only works when the lines are parallel. They have to be, otherwise it's not true because the transversal is going to be cutting them at different angles. Okay, so then let's finish out solving here. So we know this is 63, so across from it will also be 63. Then we want to take 180 minus 63 to get 117 for each of these. So now we have all of them filled out. We found all of them. So when we're given angles from each of them, we can easily solve to find the missing. The one right next to it is going to be 180 minus whatever the value you have. And then across from it, remember, is always going to be the same measure because they are congruent, because vertical angles are congruent. So like I was saying before though, alternate interior angles only works when the lines are parallel. Only works when the lines are parallel. We can see that here, that it did not work here, but it worked in the last two cases where lines DF and AC were parallel. So it only works when they're parallel. All right, so that's basically answering our number 5 here. So what do you notice about the angles in this diagram compared to the earlier diagram? How are the two diagrams different? How are they the same? So I went ahead and wrote this all out so you can see it. I know it's a little hard to read, but both pictures of the two pair of vertical angles at each, sorry, I can't even read my own writing, at each vertex are congruent. Also, adjacent angles at each vertex are supplementary. In the first picture, the angle measures at the two vertices are the same, while in the second picture, they are different. So in that last one that we did, they're different, whereas in those first two, they were the same. So the key thing there was parallel lines. We have to have parallel lines in order to take and have alternate interior angles. All right, your keyword for this lesson is interior. Interior is your key word for this lesson. If you guys have any questions, feel free to ask. Have a great day, guys.